Okay, the textbook, I think, uses A again for horizontal stretch and shrink. I chose to use B instead of A, only because I suppose you could really have both a vertical and a horizontal stretch or shrink. It doesn't really matter what letters you use for these A, B, H, K, because you're really plugging in numbers in the end. But notice the big difference here is from yesterday when we did vertical stretch and shrinks, we had that A and we would multiply it outside the f of x, so we were changing the y's, and we were just multiplying it, making it all the y's bigger or all the y's smaller by a factor of A. When we're doing horizontal stretches and shrinks, we're going to take our scalar or our factor and put it right in front of our x. So now it needs to be in that protected parentheses or absolute values, your grouping symbols, so that it's affecting x and not the y. Now notice the two statements about b. The absolute value of b is between 0 and 1. That's a horizontal stretch now. Okay? And when the absolute value of b is greater than 1, that's a horizontal shrink. So to me, horizontal stretch and shrinks remind me exactly like moving right and left. It's the opposite of what I think it will be. If the number looks small, it's actually horizontally stretching my graph. If the number looks big, it's actually horizontally shrinking my graph. So what this means, and we want to make sure we write this down in our notebooks, is that you're going to use the reciprocal of your scale factor for the value of your b. So I'm still going to say things like horizontally stretch your graph by a factor of 2. But when you put the factor of 2 in front of the x, it's actually going to look like the reciprocal, which is 1/2. So it's like when you're putting it into the function, use the reciprocal. If you see a function where the 1/2 is right in front of the x, when you pull it out, that's a factor of 2. It's the opposite of what you think it is, the reciprocal. And vice versa. If I say like horizontally shrink it by a factor of 1/2, then the b value you'll put into the function is a 2. Okay, the reciprocal. So let's do some examples. We'll start with a linear example. Let f of x equal 3x minus 2. I can tell this is linear because it doesn't have any special stuff happening to x. There's no absolute value, there's no squared, which would make it quadratic. It does have an x. It looks like mx plus b, slope of 3, y-intercept of negative 2. Okay, so remember, you know that function very well. We're going to write a new function, g of x, whose graph is a horizontal shrink by a factor of 1/2. So if we say a horizontal shrink by a factor of 1/2, what's our b value going to be? 2. Okay, so I'm going to mark that over here on the side. My b is equal to 2. In function notation, I can write that as g of x equals f of 2x, excellent, which just means in the actual function, 3x minus 2, everywhere I see x, I should write 2x. I'm just making a substitution. So my g of x is really 3 times 2x minus 2. Which is 6x minus 2. I'm gonna draw like just a real rough sketch. I'm not gonna be real exact here. But here's a rough sketch of what's happening. I'm going to draw f of x first. It goes through -2 on the y-axis, and it has a slope of 3. So I'm going to say maybe f looks something like this. It's probably a little steeper than that, really. If I change that so that my g of x is 6x minus 2, I'm still going through the same y-intercept, right? -2. But now my slope is 6. So my g looks something like that. Can you see how when you're kind of viewing it, it looks like I pushed that line in, I horizontally shrunk it, like it didn't have anywhere to go but up more, so its slope got steeper. Okay. So that's the idea behind a horizontal shrink if you're thinking about visually. Okay, so what's our g of x going to be for a horizontal stretch by a factor of 2? What's our b value going to be, I suppose? Our b value is going to be 1/2 on this one because we want to use the reciprocal. If you want to do function notation, that's going to be f of 1/2 x. Make the substitution, that's 3 times 1/2 x minus 2. And I love fractions. I'm not scared of them. I don't discriminate against them. Don't leave them out. So I'm going to leave my answer as g of x equals 3/2 x minus 2. Would it be okay if you wrote 1.5x minus 2? Yeah. The one time I don't want you to write decimals where you have fractions is if your decimals don't end. So if it's like 1/3 x, I don't want to see 0.3. Not the same thing. I don't want to see 0.333. I just want to see 1/3. Are we okay with that horizontal stretch and trace? I'm going to do one more example that is absolute value, but I'll have you guys work on it with your group. So if you want to write the function notation, you can. And then we want to try to get to that g of x function as well. So see if you can do this absolute value one with stretch and shrink for horizontals. We've got f of x is negative absolute value x minus 1 plus 2. Did you see how many numbers? You're in the front row. It looks big when you're up there. So let me see if I can see it at the wall. Yeah, I can still read it. But it is small on the board, isn't it? Oh, yeah. But what do you think about Austin's little g of x? I'm giving it a hard time today. Kind of small? Garrett says it's fine. Let's go. Oh, okay. You guys are all going to be on Austin's side. I get it. Yeah, the homework is really small. I agree. Okay, check and compare with your group members, see if you agree or disagree. Don't forget your X. That's a tiny little nitpicky thing, huh? Not if it's absolute value. Okay. absolute value is different than print. They were parentheses, yeah.
So here's what I got. You guys might know, right? This time I can't really worry. Every problem ever. I just lost some.
Okay, as I'm walking around, I'm seeing people choosing good B values. Remember, when I say by a factor of 3, your B value is actually 1/3. And when I say your B value is 3/4, then you're going to use 4/3, which is greater than 1. So it's going to be a stretch, or it's going to be a shrink, but because B is greater than 1. And then when you put those into absolute value, just remember this. It only goes in front of the x. So you just drop it in front of the x, and everything else about the absolute value function is going to stay the same. The negative out front, the -1, the +2, you don't have to change anything except for the x value. Okay. I'm going to show you just really quickly what that looks like on your Desmos, so that you can see how horizontal stretches and shrinks are working. And this is really great. Like if you've been confused all week and you're like, I don't know, I'm writing these numbers and I don't know if this is right or wrong. What you can do is go to Desmos and type in the f of x and then type in your answer and compare the pictures. Like, are the pictures doing what the book is telling you they should be doing? So I'm going to pull this over to the side. Okay, this is your f of x. This is negative absolute value of x minus 1 plus 2. So think about transformations compared to its parent function, the absolute value. It's been reflected, it's gone right 1, and it's gone up 2, which that looks like a v that's been reflected, goes right 1 and up 2. We did what first? A horizontal stretch by 3? Was that our first one? So that's going to be negative the absolute value of 1/3 x minus, oops, got to get out of there, 1/3 x minus 1 absolute value plus 2. Do you see how, like, could you imagine taking a v and horizontally stretching it when the v get wider? Yeah, and that's what it looks like, right? Your whole v got wider. If you do a horizontal shrink by 3/4, so I'll do g of x equals negative absolute value, we had 4/3 x minus 1, do that plus 2. What changes about your v? It gets a little bit skinnier, right? So it should make sense if you graph them, like how the graphs are changing. Are they moving right or left, up or down? Are you seeing vertical stretches, shrinks, or reflections? If you want to use Desmos as a tool to like help you better understand those transformations, go ahead and do that. Tomorrow, we'll focus on if we get an equation, can we then draw the graph? Okay. Okay, so your homework assignment is on page 16 again. Tomorrow you'll have a worksheet for the graphs. I have this little SpongeBob meme, right? Okay. And I don't actually mean for you to cry 37 times on your homework. So I said this early on, like when we were going through our syllabus, and I just need to say it again because we're like a few days into notes and homework, right? It is never my intention for you to be working 2 to 3 hours on math homework, pulling out your hair, yelling at all the people around you, or crying from frustration. Okay? That is never my intention. If you are feeling that way, you need to immediately talk to me. Whether that be via email or in person, we have to have open communication. It really hurts my feelings when I get an email from a parent who's described months of what sounds like torture that I'm giving you, and your parent is really upset with me, and I had no idea because you came to class all smiling and happy and pretended everything was fine, and every time I asked you if you needed help, you said no. That really hurts my feelings. So please talk to me and let me know. I want you to be successful. I want you to feel like you know what you're doing. Okay? So this meme should not be you.